Yes, class. Good evening. Am I audible?
Good evening, ma'am.
All right. Who all are present? Fatima, Hamza, Hiba, Krishna, Kulsum. Only 5 students have joined right now. Fine. So let's start with it. See, in the last class, we had stopped exactly at LCR circuits. We had completed this portion. Series LCR circuits, the formula of impedance we had derived. Now see, in case a very quick revision before we begin with it, in case of a series circuit containing only resistor, the phase difference between the current and the potential is 0 degree. Means both are in the same phase. So potential becomes IR. For a circuit having only inductor, voltage leads the current by 90 degrees. So VL is equal to XL into I. And for a capacitor, voltage lags by the 90 degree, lags by 90 degree. It lags behind current by 90 degree. So these are the three things that you have to remember for this lesson for any of the topic that we discussed. Today also we'll see some more circuits as well, RC circuits and LR circuits. For that also remembering the phase difference is very crucial. Now, then we had seen, now see impedance, the formula of impedance we had seen, it was under root R square plus XL minus XC whole square, or it's XC minus XL whole square. Now, whether it will be XL minus XC or XC minus XL just depends on the values of the potential or the values of XL or XC given. If XL is greater, write it as XL minus XC. If XC is greater, then write it as XC minus XL. But the basic formula will be Z is equal to under root R square plus XL minus XC whole square. For phase angle also, if you want to calculate what's the phase angle, you can write tan phi as XL minus XC by R or whatever. Whenever I say no, XL minus XC or XC minus XL for a series LCR circuit. LCR circuit means what? It contains all of them. So for these kinds of circuits, you have to change accordingly. See, when we'll be doing the other two circuits that are left, 4 circuits we have done till now. 1 only resistor circuit, AC circuit having only capacitor. 2, 3 so AC circuit containing only inductor, and 4th one LCR circuit we have done. Now 2 more circuits are left in your syllabus that we'll see afterward. We'll see in today's class. We'll try to complete. And cos phi is equal to R divided by HN. Then we had seen the resonance condition where XL was equal to XC. This was the main prime importance thing. This you have to remember. From here you have the value of angular frequency. Remember this class, this will angular frequency at resonance condition will be used a lot in today's class. So I'll be asking you the values. Omega R is what? 1 by under root LC. That's the formula for omega. And if you want to find out the natural frequency, it becomes 1 by 2 pi under root LC. This is the natural or the resonant frequency. Here we had stopped. And what is actually meant by resonance? Resonance is what? The resonance is basically the condition where the current's value becomes maximum. So all these topics we had covered. And one more thing. Impedance for LCR circuit at resonance is directly equal to resistance. Z is equal to R. That also we have seen because XL and XC are equal. So they'll cancel each other. I had also sent an assignment based on this only. Today also I'll send the same assignment. Because LCR circuit, as I've discussed in the last class also, this was the major chunk of AC circuit. Now 2 smaller circuits are left and quality factor we'll do at least today. These 3 topics we'll try to complete today. Q factor, RC circuit and LR circuit. So 1 or 2 classes most probably are needed for the completion of this lesson. So just let's start and revise with the help of a question. I'm writing the question, try it yourself. The one thing class, the question that I'm going to give you, the values are easy. So at least you can try and find out the values. It won't be having the values in decimal or what. You can easily calculate. And class also, one more thing I wanted to ask. Do you people now have the schedule of your half-yearly exams? Or after the school will get reopened, you will be getting the schedule and everything? Or you are aware about this half-yearlies? What is the status? What about you, Atif?
Teacher, for me, they have announced that it will start in 26th September, but they have not they have not sent the schedule.
Okay, okay, no schedule. And after the school reopens, Fatima will get to know. Akifa, what about you? And Hamza, any idea about your half yearly exams? After school, okay, no update. Fine. After the school, yes. So most probably, I think you people will be having the information when your school will start. So after 1 or 2 weeks, you'll be having. And what about you, Krishna?
No, ma'am, no schedule yet.
No schedule. Okay, okay, fine. And Kulsum, Sarah, what about you both?
It's not been informed, ma'am.
So I think once your school will start, then you all will be having your schedule. I think same will be for Hibba and others also, Joseph and fine class. So I think most probably in your half yearly exams till chapter 5 it should come maximum. Or Akifa, I remember in your school before the vacation, what was the lesson that got over, Akifa? You were ahead, I remember that time. Because I hope for your half yearlies all your chapters are over and we can have now revision classes. Because by now electric charges and field and all these lessons, we need to have a revision also for them. So that's why I wanted to know when are the half yearlies beginning and are proceeding for all of you, so that we can have a common revision class. Moving charge and magnetism was over. Okay, till chapter 4th it was fine. Fine, Akila, thank you. So note this question, try it. Please try it. At least till impedance you can tell me. Okay, Sarah, yours is there. So what's the syllabus, Sarah? Sarah, you're in India, no?
Yes, ma'am.
Okay, so what's your syllabus, Sarah?
Hotel chapter 6.
6th EMI. Okay. Class C. 3 things have been mentioned to you. This is mentioned and this frequency is mentioned. So first you have to identify which all terms have been mentioned to you, what all terms are needed. Accordingly, you will find out the current. This current is basically the IRMS. And this E is the ERMS. Fine. So you need Z to connect these and find the answer. So at least try to find out the impedance. Yes, class answers. At least tell the value of Z that is coming. Okay, class, let's discuss it. So all of you have answered correctly. Kulsum, Hamza, Krishna, and Atif. And yes, value of impedance is right, Hamza. So Hamza, I think you'll be able to calculate the current as well. See what all things are given. Hiba, can you tell what's the value of resistance that is given? Resistance. Hiba. Just look in the question, first line of the question. What's the value of resistance that is given? It's 12. Yes, perfect. That is 12 ohm. Josefa, what is this 14 ohm given? What do I call this? What's the symbol for this? No, not 12 ohm, Josefa. This is 14 ohm given, no? A resistor of 12 ohms, so resistance is 12 ohm. This is 14 ohm given. What is this 14 ohm? Is this the resistance, the capacitive reactance, inductance, capacitance? What is this? Reactance, but capacitive reactance. See, it's written what? A capacitor of reactance is this. So you have XC as 14 ohms. Fine. Fatima, what's the value of inductive reactance that is given? This was the capacitive reactance. What's the value that is of inductive reactance that is given? Fatima. No, Fatima. See, that's not the value of inductive reactance that is given. Hamza, can you answer? What is 0.1? Yes, Hamza. What's this 0.1 Henry given? Hamza, you had answered it correctly. Your answer was right. Just tell it. What was this 0.1 Henry? Sarah, can you answer? What is this 0.1 entry? Is it the inductive reactance or what? Inductance, exactly. See others, all of you listen. Just look at the unit. What is inductive reactance? What is capacitive reactance? All these are actually the resistances for all these respective circuits. So here value of inductance is given. Inductance was what? Self-inductance. Remember we did 0.1. Henry, just look at the unit. It's not written ohms over here. So this is the inductance that is given. And XL will be calculated by omega L. I do not have the value of omega. So I'll write it in terms of 2 pi. So this becomes 2 pi mu L. If you convert this, frequency is given as 50 hertz. XL will be 2 into pi is written, take it as 3 into 50 into 0.1. So this will be 30, yes. This will be 30 ohms. Fine. Now you have value of XL, XCR is there. So calculation of impedance requires what? See, why are we actually trying to find out the value of impedance? What's the need? Because the question is asking us to find out the value of current. Why are we finding? See, ERMS is given to us as 200. 200 volt. We need to find IRMS. So what's the connecting equation between current and voltage? Obviously, current is equal to voltage divided by the resistance. And for AC LCR circuit, we all know that the resistance, net resistance for that circuit is the impedance. So here you will write IRMS as ERMS divided by Z. Now Z is unknown. For that, we can perform this calculation. R square. R क्या था? R was 12. So 12 whole square plus. Now XL is 30 ohm. XC is 14 ohms. So we will write XL minus XC whole square. This Z becomes under root 12 square plus this becomes what? 30 minus 14 whole square. See class, this will be 16 square. So 196 you have it. And you have here, no, this is 144. So that will be complete 400. 144 plus 256. That will give you complete 400. So this becomes 20 ohms. This is the net value of impedance that you have. Now you can easily find out the value of current. What will be the current? See, current will be equal to IRMS will be equal to 200 divided by 20. That is 10 amperes. Regarding the second part, tan phi, what did I just revise with you people? XL minus XC divided by resistance. So here you have 30 minus 14 divided by 12. You can write it as 16 divided by 12. So tan phi can also be written as, this becomes 4 by 3. This becomes 4 by 3. So phi becomes equal to tan inverse 4 by 3. This is the answer. And you can write it in terms of inverse square function only. You can leave the answer in terms of inverse trigonometric function. Just note down the solution. Then we'll do some other topic. See class, now the next topic, that is Q factor. So this is not a separate topic. This is a part of resonance only, because you have Q basically means what? Q means quality. So you have the quality factor or Q factor in case of resonance only, whenever there's the condition of resonance is fulfilled. So Q means what? Q factor is basically the quality factor, which we say quality factor. So in your exams, this can come in the sense, what do you mean by sharpness of resonance in a series resonance circuit, or find the expression for Q factor of the circuit. So we'll have a small derivation also, not actually a small, it's a lengthy derivation. The only lengthy derivation among these ACMI and all these lessons. So that we will see. Before that, just understand what is this Q factor. See, Q factor basically, this measures the sharpness of resonance. It measures the sharpness of resonance. So let me show you a graph first. This is the peak values of current on this axis, that is your y-axis. On the x-axis, I have the values of angular frequency. Now, obviously, wherever the current will be less, here the value of current is less in comparison to others. So here the value of resistance that I'll get, it will be what? It will be a high resistance. Then at this value, this is a slighter bigger value of current. So here the value of resistance that I will get will be moderate value of resistance. Here I will get moderate resistance. And here the value of current is maximum. So here the resistance that I'll get, this will be low resistance. Now add this. Here, this is the resonant frequency. Fine. So this shows what? This shows the variation of current amplitude I naught in a series LCR circuit with what? With the angular frequency omega. So for three different values of R, low value, moderate value, high value, this is the variation. So current amplitude has a peak at the resonance frequency. This you can see, this is what? This is the resonance frequency. Peak is exactly at the resonance frequency. And what was the value of resonance frequency? Before starting with today's class only, I have discussed with you. Yes, Akifa, what was the value of resonant frequency? Akifa, resonant frequency. Angular frequency, what's the value of it? In terms of inductance and capacitance, we had seen. Atif, can you answer?
Root LC?
Yes, 1 by root LC, not root LC. It's 1 over root LC. Exactly. So exactly at this value that you have, the current has its peak value and falls to 0 in either direction. You can see in either direction, it will ultimately fall to 0. So the resonant frequency is independent of the resistance. But the sharpness of peak, that you can see it depends on the resistance. Definitely, resonant frequency was what? Resonant frequency does not have R in it. But the sharpness or the peak of the graph, that depends on the values of resistance. If resistance is low, you have a peaker graph. The graph is sharp. So peak is higher for smaller values of R. Thus, the resonance is sharp for small values of R and flat one for large values of R. This is comparatively a flat one graph. So the sharpness of this resonance, this is measured by the coefficient that we call as the quality factor or the Q factor. This is just for your understanding. For that, let me just tell you what's the actual definition of it, Q factor. So this Q factor of series, remember this is for series resonance circuits. So Q factor of series resonant circuit is defined as the ratio of the resonant frequency I'll explain you this resonant frequency. So on the numerator, you have what? The resonant frequency. To what? To the difference in two frequencies taken on both sides of the resonant frequency such that at each frequency the current amplitude in the exam you have to write this definition. This is the main definition. Amplitude becomes 1 by √2 times the value at resonant frequency. Now I'll explain you what is meant by all of these sentences. All these words means what? Frequencies. C class. Let me draw that graph once again. A graph I had drawn before explaining what was the sharpness. This is the graph. Here you have values of current. Here you have values of angular frequency. Fine. I'll just draw one value because right now we are not comparing all the different resistances value that we have. Let's say 1 I have drawn. Now just look over here. This peak value, where the current is maximum, we call this only as the resonant frequency. Remember what was resonance condition? Resonance condition was when current was at the maximum. So from this graph, you can predict that this is the maximum value of current. So definitely this point will be resonant frequency. Now let me just mark 2 points on either sides of it. This is one frequency. This is another frequency. Fine. So this says what? Q factor is basically, it's the ratio of the resonant frequency and the difference in these frequencies means this. Difference in these frequencies. This is what is meant by Q factor. This is, known as what? This is known as the bandwidth. So if you call this term as delta omega, and this term will also be delta omega. So this complete term, this becomes 2 delta omega. So Q is what? This can also be written as the resonant frequency divided by the bandwidth. Resonant, obviously this is what? Resonant frequency, and this difference between them is the bandwidth. So this you can, in terms of words, you can write, but basically it was what? Omega R means resonant frequency to the difference in these two frequencies which are taken on both sides of it. Fine, this was what is meant, or you can write this way also, omega R divided by 2 delta omega. Any of these is valid. Maximum times this one is used, and this is the main thing. Also, value of, let's say, current at this maximum value, let's say this is E0 divided by R. So at this value, no, at the value for the Q factor, calculation of Q factor, this frequency that we take, here the value of current, it becomes 1 by root 2 times. Fine. Now read the sentences back, what I've written. Q factor is what? Firstly, it's valid only for resonance condition, because without resonance, you will not be having the value of angular frequency as 1 by under root LC. So it's valid for what? It's valid only for the resonance circuit. So Q factor of series resonance circuit. This is defined as the ratio of. So ratio of what? Firstly, the resonant frequency to the difference in the two frequencies. Basically, the difference in the two frequencies. That is omega 1, omega 2 minus omega 1. So omega r divided by omega 2 minus 1. Till here, this is written. And frequencies are what? These are taken on both sides of the resonant frequency. Fine, clear till here? It's the ratio of resonant frequency divided by the difference in the two frequencies. Addition point is that such that at each frequency, current amplitude becomes 1 by root 2 times the value at the resonant frequency. If current is E naught by R at the resonant frequency, it becomes E naught divided by root 2 R. That is what is meant by quality factor. You still have a very small derivation left that we'll do. But is this clear? Bandwidth, resonant frequency, and all these. Yes or no? Understood?
Yes, ma'am.
So note this down, then we'll do the derivation. Written. See, current's value was what? There's one more derivation of Q factor that we have. So here we had value of current as what? This was E naught divided by root 2R. And at resonance, what have we studied? We have studied at resonance the value of impedance, that is Z, becomes equal to resistance. And here we do not have the value of resistance as R. We have the value as root 2R. And the ultimate formula for Z was R square XL, so I can write it as omega L, minus XC, so 1 by omega C whole square is equal to root 2R this time. Clear? This is the formula for Z. Z was no under root R square plus XL minus XC whole square. This only I have written in XL in terms of omega L and I have expressed XC in terms of 1 by omega C. Fine? So I'll square both the sides. So if when I square both the sides, this becomes R square plus omega L minus 1 by omega C whole square. This root will go on. This will be 2R square. See class, from here, 2R square minus R square will give you R square only. This, both these will get subtracted. So omega L minus 1 by omega C whole square, this will be equal to R square. Right class, this will be equal to R square. Now omega, first value of omega, angular frequency that we had. If I write that, it will be equal to what? This will be equal to plus R. Or let's say, see, omega L minus 1 by omega C, just look here. This will be equal to what? Plus minus R if you take root on both the sides. So one of the values will be minus R and the other value will be what? Plus R. Is it clear till here? These two are very important. We had written omega L minus 1 by omega C as plus minus R. So one of the values on either side of the resonant frequency, omega 1 becomes minus R and value of this becomes plus R. Now just these two equations are required for the solving of our values and getting our answer. Now if I add these two equations, let me just add these two equations. So if I add 1 and 2, see what will I get? Omega 1L plus omega 2L. So omega 1 plus omega 2L. Right? So omega 1L plus omega 2L. Clear? Now if I take, now here what is left? If I take 1 by C common, I'll be left with 1 by omega 1 minus 1 by omega 2. And minus R plus R will give me 0. From here, I have the value of 1 by C as what? Take the LCM, this becomes omega 2 minus omega 1 divided by omega 1 into omega 2. Transport this on the other side, this becomes omega 1 plus, this will be plus, minus I've taken common, no. Plus omega 2 divided by, no, multiplied by L. From here, if you look, omega 1 plus omega 2 and from here omega 1 plus omega 2 will get cancelled. What do we have? By adding these two equations, I am getting the value of omega 1 into omega 2 as what? 1 by, this will be LC. L will come here, omega 1, omega 2 will go there. Fine. So this is one more equation that will be required. Using these two equations, I have got this. Now, if I somewhat subtract these two, if I subtract 1 and 2, I had added, no, these two. If I subtract them, if I subtract these two means, instead of wherever I was getting plus, I'll be getting minus. So this becomes omega 2 minus omega 1, L, plus 1 by C. And this will be 1 by omega 1 minus 1 by omega 2. And see class, here it won't be 0 because you do not have plus R minus R this time. This is R minus R because subtraction is there. So this becomes 2R. In addition, plus R minus R becomes 0. In subtraction, that negative sign also gets converted. So you get the value as plus. All right. So let's just cross multiply this. Omega 2 minus omega 1 into L plus 1 by C. Omega 2 minus omega 1 divided by omega 1 into omega 2. Two things I can do, class. I can take omega 2 minus omega 1 common. And right now only I had got the value of omega 1 into omega 2. Why did I even calculate this value? Was for solvation of this step only. Here I have the value of omega 1 by omega 2. Here is the value, no? Yahan pe. See this value of omega that I have. So if I substitute and put it here, and I'm taking omega 2 minus omega 1 common. Two things I'm doing. So taking omega 2 minus omega 1 common will give me L. If I take omega 2 minus omega 1 common, from here only L will be left. From here plus 1 by C into this term will be left. And this term is what? This came out to be 1 by LC. So this will be 1 by LC equal to 2R. C will get cancelled. What is left? Omega 2 minus omega 1 into 2L is equal to 2R. 2 gets cancelled. Omega 2 minus omega 1 comes out to be R divided by L. This is one more thing that was required. So we get this, we obtain this by subtracting it. Now, omega is, Q is what? Q was resonant frequency divided by omega 2 minus omega 1. Ultimately, we had done everything to get the value of omega 2 minus omega 1. So you have omega R, omega 2 minus omega 1 is what? R by L. So Q is what? Omega R L by R. Where R is resistance, L is inductance, and omega R is the resonant frequency. And I'll write this also. This is the resistance, this is the inductance, and this is the resonant frequency. Now, one more thing we can do. See, omega R is what? 1 by under root LC. Square both the terms. If you square this term 2 times, you will be getting 1 by LC only. Just keep 1 omega here and transport L over here. So what it becomes? It becomes omega R into L is equal to 1 by omega R into C. I can write it in this way. L can be shifted here. Omega R can be kept here. What is this? Why have I written this? Because omega R square can be written as omega R into omega. That's why I've written this step. Now class, omega R into L. If you look from here, omega R into L is what? This is Q multiplied by R. That is quality factor multiplied by the resonance. So this is nothing but Q into R is 1 by omega R into C. Omega R is also 1 by under root LC divided by C. From here you get the value of resonance Q factor as 1 by R. And root will be left, root L by C. This is one of the other formulas that is required. Q is equal to 1 by R under root L by C. L is inductance, C is capacitance, R is resistance. All three are utilized. This is the derivation. I'll just quickly repeat it. It's a lengthy derivation. Chances of this coming in the exam are least. These types of derivation do not come most in your exams, but there's a chance it can come. Impedance is what? Impedance is equal to the value of resistance at resonance. So Z is equal to under root 2R. From here I have put the value of Z and I've got two equations. Omega L minus 1 by omega C. 1 is equal to minus R, and for 2 it came out to be 2. These two equations. First tell me, any doubts in these two equations till this step? Till this step, is it clear? Clear to others as well?
Yes,
Fatima, Sarah, Kulsum, Hanifa, did you understand?
Yes.
So these two equations, if these are clear now, you just have to apply mathematics. Till here you had to apply all your physics of that you have studied from EMI, AC. That impedance is equal to resistance and the formula of impedance. Now, if you add these two equations, you get the value of omega 1 into omega 2 as 1 by LC. Why did we do it? Because when we subtracted to get the value of omega 2 minus omega 1, when we subtracted, we had to obtain the value of omega 1 into omega 2. So since we had already calculated it, using those values, we calculated the value of omega 2 minus omega 1 as R by L. From here, omega Q came out to be omega R L by R. And value of another formula for quality factor comes out to be 1 by R under root L by C. So this is also there in your syllabus. Just revise this term. Are you people even revising all these AC, alternating current and everything? Have you started with AC? I'll soon take a test of AC. Let me just tell you the date. For full complete chapter. Almost we are towards the end of this lesson. So today is 30th August. Then we have class on 1st. Leave 1st. Till 1st we'll be able to do the lesson. Then 6th September, Tuesday. Okay, leave Tuesday as well. 8th of September, you have a complete full test of AC. September, you have a full test on AC, this whole lesson. What's the phase difference between these two, resistance and capacitance, which is leading what, which is lagging behind, all these terms should be clear. Now see in this question it says in a series LCR circuit, the resonant frequency is 800 hertz. So it means omega R is what? Omega R is equal to 800 hertz. The half power point means the first and second frequencies, these two. So first one is 745 hertz. Second one is 855 hertz. For calculation of Q factor is what? Omega R divided by omega 2 minus omega 1. So omega R is 800 divided by 855 minus 745. 110, no? This is 0, 1, 1. Yes, 110. So Q will be 800 divided by 110. So 11 into 7 is 77. So this will be around 7.27 something. And it's a unitless quantity, unitless and dimensionless, because frequency is above also and frequency is below also in the denominator. So it will be 0. And answer for this is the answer for the first Q factor, and answer for the second part. That is the bandwidth. Bandwidth is what? This is omega 2 minus omega 1. This will be only 110. All right, class, copy it down, and the last two circuits that were left that we'll discuss. Just note it down. Done? Just text me done in the chat box, those who have written. Fine. So last two circuits that are left. So please revise all those four circuits that we have already done. Circuit with only resistor, circuit with only capacitor, circuit with only inductor. 3 here, LCR circuit, and now series LR circuit. So LCR had L, C, and R. LR will have what? It will have a resistor along with an inductor only. So if you have actually understood LCR circuits concept, then understanding this is very easy. This is resistance, this is the inductance. Voltage will be VL, which will be equal to XL into I. VR will be equal to I into R. Current and resistance are in the same phase for resistor. In case of potential, potential leads the current by 90 degrees. This is E naught sine omega t. See here, the derivation and everything, this becomes very easy. Before we do that, let's just, if you represent it on a phasor, if this is the value of the resistance, or let's say this is the value of VR. So in case of an inductor, this leads the current VL by how much? 90 degrees or pi by 2. This will be again omega t minus theta and everything. Those things will remain the same. Here, no, if you put and take the using Pythagorean theorem. So if you apply Pythagorean theorem, you will get E naught square equal to what? VR square plus VL square. Using Pythagoras theorem, if you apply it, E naught square will be equal to VR square plus VL square. Put in the values of VR. VR will be equal to I naught square R square plus I naught square XL square. From here, if you take I naught square common, you are left with R square plus XL whole square. So I naught square is equal to what? E naught square divided by under root, not under root. I naught from here, if you transport this becomes R square plus XL square. From here, if you write just the value of I naught, if you take this root common, squares common from here, you will be left with under root R square plus X square. C's impedance is what? This is just R square plus X square. Your work has been reduced. It has become now easier. The impedance earlier, which had XL and XC both, now has only XL along with the resistance. Even this will be valid in case of tan phi. Tan phi, no, that was XL minus XC divided by R. This time it will be only XL divided by R, or you can say VL divided by VR. This much it will be there. Fine. So this you can write XL, you can write omega ln. So E is what? E is E naught sine omega t. I is what? This is I naught sine omega t minus whatever is the phase difference. This is the main thing in case of what do we have? LR circuit. Fine, just note it down. Numerical, I'll give you, try on it. So see, in case of the individual resistors and circuit, you had the values in differently. You had the values of VL, VR, VC, and all these individually. For LCR circuit, you combined all and you got all the values of it. Now, in case of LR circuit, you will be having just the inductors component and the resistors component. So most of the things get reduced. Just note this down as well. See, a resistor is given and an inductor is given, which is connected to an AC coil. Now the voltage of the resistor is 90 volts and the voltage across the inductor is 120 volts, and you have to find out the impedance first. So impedance, for finding out the impedance, we require what? We at least require the IRMS, which is given, that we already have. We need to find the ERMS, then only we can find it. So ERMS will be equal to what? ERMS will be simply equal to VR square plus VL square. From here only, no, we had started our derivation. So it will be under root VL square plus VR square. This will be under root 90 whole square plus 120 whole square. So ERMS will be what? 150, right? 150 volts. So what do we need? We need impedance. Impedance is V for the first part. VRMS divided by IRMS. This is 150 divided by 3, that is 50 ohms. Secondly, for the phase angle, see tan phi is equal to what? Tan phi is equal to XL divided by R. Or you can, instead of XL, we do not have any information regarding XL, so we can write VL divided by VR. So this will be equal to what? This will be equal to 120 divided by 90, which is equal to 4 by 3. Again, this answer will also be tan inverse C. Tan phi is equal to 4 by 3. So phi will be equal to tan inverse 4 by. Note this down, then one last circuit we'll do and then we'll wrap up the class. Any doubts? If you have any doubts, just text me or just unmute yourself and ask me. All of you have done? Now one last circuit is left. One last circuit from all these circuits. Series RC circuit or CR circuit. This is what? This is series CR circuit. Now this is also easy. See, that's why we did LCR circuit first. So once you have the grip of LCR circuit, now one component can get deleted and still there won't be any. This is a resistor, and from C you can definitely understand that the capacitor is connected. This will be E naught sine omega t. This is capacitance, this is resistance. Both are in the same phase for resistance, and voltage lags behind by 90 degree in case of capacitor. These lines, I think I have repeated it so many times. When we were doing LCR circuit, when we did all these circuits individually, when we revised LCR circuit in today's class also. So I hope you remember all these. Please revise. On 8th, I'll take your subjective test. So VR is equal to IR and VC is equal to what? I into XC, right class? All these things are there. So even if you draw the phasor, if this is VR, VC will be here. VC will be here. Remember, for the complete circuit, we combined both of these. And this will be having 5 by 2. Now, the simple derivation part is not tough. This time, E naught square will be equal to VR square plus VC square. E naught square. VR is what? Potential of the resistance is what? Current multiplied by the resistance. And square this plus current multiplied by the resistance of capacitive. That is capacitive reactance. Square of this. E naught square, take I naught square common from both of these. R square plus XC square is left. From here, I naught square can be written as E naught square divided by R square plus XC whole square. Now from here, I naught, if you write, I naught will be equal to E naught divided by under root R square plus XC square. Right class? So Z will be equal to what? R square plus XC square. So all the components of inductance have been removed, and instead of it, capacitance has been added. And same goes for tan phi. For tan phi, you can write this as XC divided by R or VC divided by R. Any of these things will go well. Remember, cos phi will ultimate in all of these, no, cos phi will be equal to R by Z. Z is different here, so you can change the value of Z accordingly. But these basic lines remain the same. Note this down as well. Please start revising. If you have understood which leads what and remember the formula, then this chapter is easy. But if you get confused between what is leading what, which is lagging behind, so you'll not be able to construct the formula. So many formulas you cannot remember. Some things you have to derive it on the spot as well. So please revise it, start preparing for your test. When you all will complete, just text me done in the chat column.
Teacher will be VC by VR, right?
Yes, not resistance. It will be VC by VR, right? XC by R and VC by VR. Fine, all those who have completed, you can leave. Now, let me just tell you. Power and energy is left, LC oscillation and transformers. These topics are left from your lesson. So, the next class on Thursday, I think we'll try